Let's look at the laws of indices. The first law, a to the m times a to the n is equal to a to the m plus n. So in other words, if you are multiplying by the same base, the base is a here. You see how it's the same base? It's a to the m times a to the n. Once you have that same base, you simply add the indices. So for example, if you had 2 to the power of 3 times 2 to the power of 2, well, this would just be 2 to the power of 3 plus 2, which is equal to 2 to the power of 5. The next one, which is similar to the first one except it's division, you still have the same base, so when you are dividing by the same base, you simply subtract the indices. So if you have a to the m divided by a to the n, the answer will just be a to the m minus n. Let's look at an example. If you have 3 to the power of 6 divided by 3 to the power of 3, this would be 3 to the power of 6 take away 3, which is 3 to the power of 3. All right, so for these two rules here, the base must be the same. It has to be the same base, otherwise these rules do not apply. The third one is that a raised to the power of 0 is 1. Any number raised to the power of 0 will be 1. Even if you had 1,000 raised to the power of 0, the answer will still be 1. So any number raised to the power of 0 is 1. Number 4, a to the power of 1 is a. So any number raised to the power of 1 is itself. So even if you had 593 raised to the power of 1, it'll still just be 593. The next rule, a to the power of m all raised to the power of n would give you a to the power of m times n. So you multiply the indices here, right? So this would be, let's look at an example here. If you had 2 to the power of 3, all raised to the power of 2, this would actually be 2 to the power of 3 times 2, which will give me 2 to the power of 6. All right, now this one is interesting. This one, number 6, is a to the negative m is equal to 1 over a to the m. So how I like to think about it is this negative sign here translates to just be 1 over, and then it'll just be a to the m, right? So let's look at that with an example. If I had 6 to the power of negative 2, well, the negative translates to be 1 over, and then it'll just be 6 squared below, right? Which is, we can work this out quick. 1 over 6 squared is 36. So anytime you have this minus, whenever you have a negative power, it just translates to be 1 over the base raised to the power. So look at another example with that same one. Say I had 8 to the power of negative 3. Well, the negative translates to be 1 over. And then below you'll have 8 over 3. So this is 1 over 8 times 8 times 8. I actually don't know what that is off the top of my head, so I will just move on to the next one. All right, the next one is um, a to the m over n. So when you have a base raised to a fraction, an index that is a fraction, what I like to think of it as whatever the denominator is tells me what root I would have to take, and then the numerator tells me how much I have to raise, what power I need to raise the base to, right? So this will be the nth root of a to the power of m. So let's look at an example with that. If I had, for example, let's say I had 4 raised to the power of a half, right? So again, the denominator is 2. So that means I'm going to be looking at the second root or the square root. And it will be 4, the base, raised to the power of the numerator here, which is 1. So this would be, we could find this out because 4 to the power of 1 is itself 4, and the square root of 4 is 2, right? Another example like that, let's say I had 100 raised to the power of 2 over 3, right? Well, again, the denominator tells me which root I will be taking. So it will be the third root or the cube root of 100, the base, raised to the power of the numerator, which is 2. All right?